So in 3D Pythagoras, what you have to do is look for the two-dimensional shapes, two-dimensional triangles, right-angle triangles, looking in, hiding inside the shape, and it's always Socrates or Pythagoras. And this is kind of an unusual question. Normally they give you BC and you have to calculate AC and then calculate 16, and we're going the opposite direction because 16 represents the distance from F to C. And the triangle FAC I've drawn here, and you can see that I can use Pythagoras to calculate that AC is 2 root 55. And then if I look at the triangle ABC, which I've drawn here, okay, I can use those lengths, using Pythagoras again, to calculate that BC is 12.5. It's the second part that I thought was particularly unusual in this question. I have never seen anyone where they've got to work out the angle between the plane when the plane wasn't the floor, but in this case they actually asked for the plane ABGF, and that is this bit I've shaded in here. So, and it's a little more difficult to see what angle is they've wanted. And so what I did in my mind was to lift the shoebox up onto its end so that this plane that they wanted did become the ground. And so C would now be vertically above B, again H would be vertically above G, and I've drawn that here. And once you've drawn that, with this being sort of the axes of the tilt, and this kind of fell over like this, then you can draw in FC and see that the angle that you want is CFB. Now FC they've given to us 16, and BC we calculated in the previous question, and I've put down, that's supposed to be an 8 by the way, a more accurate version of the 12.5, okay, because I wanted to keep the number accurate. And so I've used sine opposite over hypotenuse and downshift sine, and worked out the angle is 51.3. Now here we've got a quadratic inequality. Now the ones you're probably going to get in the real exam is going to be a bit more difficult than this. This is part of the old spec. So I'm going to move everything over to one side and go 3x squared and 5 and take away 53. It's going to be giving minus 48. Okay, and what I want to do, this, as you can see, is happy. Okay, so it's going to be looking like that, and I want to find out the critical values. Where does it cross here? The ones that's kind of easy to factorize, because I can take 3 out and I get x squared minus 16 equals 0. And hopefully you can recognize the difference of 2 squares here. So this actually factorizes 3x minus 4, x plus 4 is equal to 0. And so I can see that my answers are 4 and minus 4. So this must be minus 4 and that must be 4. Now if I put the inequality back, they want the bit that's less than 0, okay, less than 0. So I'm looking for this bit here, okay, not that bit, not that bit, this bit here. So I need x to be minus 4 to be less than x, okay, and less than 50 and less than plus 4.